Based on a demonstration where a piece of paper is ripped in half and then half again and then half again, we're going to follow up on it where what if it's ripped into thirds? And we discard a third of the piece of paper. Now this is not going to be an exact science, but if I broke this into roughly thirds and said, okay, I'm going to rip this off and this portion is just going to go away. Okay, now I've got 2/3 left. Okay, I'm cutting things in, well, actually this is the shaded region, so this is what I have left. I'm cutting things in thirds. Okay, so if I'm cutting something into thirds, then this is what I have left. Now what I have left, I'm now going to cut into thirds. Okay, this way and this way, where now this is the only portion that I have left, and I'm going to take that now, I'm going to cut it into thirds. Okay, and then this now is the only portion I have left. Okay, and then I'm going to cut that into thirds, and then this is the only portion that I have left. But as I'm saying this is the portion I have left, this is I'm saying this is what's being removed, this is what's being removed, this is what's being removed, and each time I cut it in thirds, I have a certain amount that's left, right? Okay, that much left, that much is left. Now the portion that we've removed is filling up the complete piece of paper that we see here. As I continue to cut into thirds, I'm going to get close. I can do this an infinite number of times in theory because there's always going to be a certain amount left to cut into thirds. And as I'm adding these things up, this is what's been discarded. I'm going to add that to this, which was discarded. I'm going to add that to this, which was discarded, and add that to this. And as I see what I have, the portion that I'm discarding is getting smaller and smaller and smaller, but I'm still adding that to the pile that I have left. And so if you can kind of look at that, what I have left is always going to be the amount of paper that I have left. So the question of would the infinite sum be different? Looks like what's happening here is that the sum of all these, as I continue to do it, smaller and smaller and smaller amount that I'm removing, I'm going to have what's left is going to be basically this completed piece of paper. So the answer is no. You can explain that in your own words. Do I need to leave it at that? Is it possible to add an infinite number of things? The answer is yes. And the answer is yes by that demonstration. As we remove a smaller and smaller amount, we are getting closer and closer to the entire piece of paper that we had to begin with. So the sum of this infinite geometric series is actually going to equal 1. Is it possible to add up an infinite geometric sequence when it's increasing, decreasing, or both? Yeah, the answer to both is yes. Okay, if it's increasing, it's going to get bigger to a point. Well, actually, I guess you can add it up. Yes, as it's getting bigger by a larger amount, we're going to be adding an infinitely large number of things. So yes, one answer, if it's getting bigger, the answer would in fact be an infinitely big number. But if it's getting smaller, there will be a finite number. There will be a number that exists. So bigger, the answer is going to be infinite. Smaller, it will actually flatten out to a number, and we'll see that in just a second.